All right, welcome. Today we're going to talk about decomposing fractions, okay, and what that means. So make sure you have your listening ears on and you're in a nice quiet spot and you are ready to learn. So let's talk about what decompose means, right? It means to break down. So some people decompose things in their garden, right? So apples can decompose. They won't be trash forever. They'll break down into nothingness, right? So we can break down numbers. And so when we're starting a new concept, I like to go back to an old concept. So decompose a number. So let's say we say 5, right? We want to break down 5 into smaller units. We could say 4 plus 1, 3 plus 2, 1 plus 1 plus 1 plus 1 plus 1, 2 plus 2 plus 1, 1 plus 1 plus 1 plus 2, right? So when you're decomposing a number in general, there's not really a wrong way to do it. There's a lot of different ways you could decompose a number, especially as you get to larger numbers, right? So let's now talk about how does this relate to fractions? How are we going to break down fractions? Okay, so let's look. All right, so it says decompose a fraction. So here we have 3/4, and we can clearly see that this is divided up into 4 equal parts, and 3 is colored in. So 4 is our total, right? The denominator is the total. 3 is the pieces that are colored in. So if I was going to decompose 3/4, I could say 2/4 plus 1/4, right? Still gives me 3/4. Or I could say 1/4 plus 1/4 plus 1/4, okay? We're breaking it down. All right, let's look at a different one, okay? Let's look at 3/5. Okay? Decompose a fraction, so 3/5. Now notice this time I put the unit fraction inside, right? 5 is the denominator, which means the total pieces. And this is made up of 1/5, 1/5, 1/5, 1/5, 1/5. So 1/5 is the unit fraction, right? This is fifths. And so I have colored 3/5, right? So this is what this shows. So I could decompose the fraction to 1/5 plus 1/5 plus 1/5. So I decomposed the unit fractions. All right. I could also have done 2/5 plus 1/5, right? That's also decomposing it, just in a different way. All right. And if we want to kind of put a story to it, so again, if we're just talking numbers, sometimes it gets confusing. But if we were to say, if we even go back up here and make it personal, right? Make those connections. So let's pretend it's a candy bar, 1 piece for you, 1 piece you gave to the teacher, 1 piece you gave to your friend. Okay, you still gave away 3/5 of your candy bar, but 1 piece was for you, 1 piece was for the teacher, 1 piece was for your friend. So 1/5, 1/5, 1/5. Here, let's make it personal, okay? So maybe this time you ate 2/5 and you gave 1/5 to your friend. The total that you gave away was still 3/5, but you broke it up differently, right? So let's continue. 5/6. Okay, so let's look at our picture here, right? 1, 2, 3, 4, 5, 6. There's 6 pieces. And as you can see, right, the unit fraction, this is 1/6, this is 1/6, 1/6, 1/6, 1/6, and 1/6. And 5 of these 6s are colored in, right? 1, 2, 3, 4, 5. So this gives us the fraction 5/6. All right, so if we're decomposing the fraction or breaking it up, we could break it up into 1 piece for you, 1 piece for your mom, 1 piece for your sister, 1 piece for your brother, 1 piece for your dad. That's how you broke it up. Okay, so 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. And you can make your own stories, that make sense to you as you go along. So that's one way to decompose 5/6. And we decompose it using the unit fractions, right? That's always a way that's going to work. Is there another way? Yeah, sure, there's another way. There's plenty of ways. Here, we could have done 2/6. So maybe I took 2 pieces, right? And then I gave one to my mom, one to my dad, and one to my younger sibling because we didn't want her to cry. Or we didn't want him to cry, right? So 2/6 plus 1/6 plus 1/6 plus 1/6, right? 2, 3, 4, 5. We still have 5 colored in out of the 6 pieces. Okay. See, there's another way yet still. Okay. And here we have 4/6 plus 1/6. So maybe I was really hungry. On my way to school, I ate 4 of the pieces, right? And then I gave one to my friend when I got to school. So 5/6 were still gone of my candy bar. Okay. So we broke it down. We broke down 5/6 3 different ways. We broke it down unit fraction, 1/6, 1/6, 1/6, 1/6, 1/6. We broke it down 2/6, 1/6, 1/6, 1/6, and we broke it down 4/6 plus 1/6. There's a few other ways we could break down 5/6, but I'm not going to get into that right now because I'm sure that we could do that, right? Because even here, 2/6, right? I could loop these into a 3/6 and say that I gave 3 pieces to the music teacher. So that would be another way, but we don't want to go into just that. We want to keep looking at different ones. So let's go to the 6/8. Okay, and so I have my fractions over here. We have 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8 total pieces, right? That's why we have the denominator 8, and 6 are colored in. So again, if we're decomposing it, we can say 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. That gives us 6/8, right? We could also break it down into 4/8 and 2/8. So, I ate 4 of the 8 pieces, and then I gave 2 of the 8 pieces to my best friend. Right? Notice the denominator is not changing in any of these scenarios, right? Only the numerators are changing because the total pieces of the candy bar are not changing, or the cake, or the pizza, or whatever you're visualizing right now. The total amount of pieces that we're starting with aren't changing. The amount that we're eating is, right? So, or the amount that we're coloring in. So the numerator is the only piece that's changing, right? But the denominator is staying the same. So we've looked at 6/8 and we did it with the unit fraction. And here we did 4/8 plus 2/8 because 4 plus 2 is 6. The 8s, we're talking about the same amount of pieces. We could do it like this. We could say 5/8 plus 1/8. Right? So maybe I ate 5 pieces. 1, 2, 3, 4, 5. These were mine. And then, I gave one to my neighbor. But still 6/8 of the candy bar is gone. Okay? We're breaking it up into different combinations. All right, so does that make sense? All right, so let's look, if we were to look at this. Which expression shows 4/10 as a sum of a unit fraction? So let's think about what sum means, right? Sum is the answer to an addition problem, okay? And unit fraction, okay? So this is an important word. We need to know what sum means, right? So let's do this, right? Answer to an addition problem. And unit fractions. Let's put this in a different color, okay? So like I said earlier, even on this last one right here, okay, we know that there's 8 pieces. So that means 1/8, 1/8. Those are the units. Those are the units fractions of eighths. So when we're breaking it up into the unit fraction, we're saying 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. That's the unit fraction. If they just said decompose the number, or find the sum of this fraction, then we could look at 4/8 and 2/8, because that is, we're decomposing it, and 4/8 plus 2/8 does equal 6/8. Okay, and then here 5/8 plus 1/8, that does equal 6/8. But they're looking for something specific here. They're looking for the sum of the unit fractions. Okay, so they're looking for the unit pieces. So 4/10. So would we say that A represents the sum of the unit fractions? So now let's look. We have 4/10. Tenths is our denominator. Remember, we said our denominator did not change. So right away, I should be saying, okay, I have to look for an answer that has tenths, because that's not going to change. So I know right away that this one is wrong, and I know that this one is wrong, because it should be in tenths. That is not going to change. So I'm going to look here. Okay, 1/10 plus 1/10 plus 1/10 plus 1/10 equals 4/10. So this is your answer. Okay. And, I hate to say that they're going to try to trick you. I don't know if it's trick is the word, but they're going to put numbers in there that could confuse you. So see, they'll put 4s, right? Because there's a 4 here. So if you're not really sure what you're talking about, you might pick this one because you see that 4, right? You might pick this one because 8 plus 2 equals 10. But we don't add denominators because the pieces don't change. So really, don't let them fool you. When you are looking at something like this, know that there has to be a 10 on the bottom. Has to be, okay? And then ignore everything else, because those can't be possible choices. All right, so which expression shows 3/12 as a sum? So again, we know what that word means, right? Has to be an addition equation, and they want the unit fraction. So the unit fraction. So 3/12. Change the thing a little bit here. So what did we want to do first? We want to look at those denominators, right? 12. Okay, well, this one has a 12, right? But this one doesn't. Oh, notice they try to trick here. 10, 2, that's 12, right? So if you're not really paying attention, you might think, oh, that's a good choice. And this has a 12 and this has a 3, right? No, we want the sum. So the denominators have to be the same and they have to match what's up here. So 12, 12, 12, good. And then 1, 2, 3, good. So this would be our choice right here, because 1/12 plus 1/12 plus 1/12 equals 3/12. Just want to highlight this one. I'm going to highlight that then. Okay, that's our answer. Okay, let's try another one. All right. Which expression shows 8/10 as a sum? We need addition of the unit fractions. So units. All right, let me focus in on my denominator. Tenths. All right, I already see. I see what they're doing here. They gave me a 10. They gave me an 8. They're trying to trick me. They put the 8 as a denominator, right? And they gave us 10 of those. No, we know what we're doing. The 10 has to match the 10 on the bottom. So let's just count. 1, 2, 3, 4, 5, 6, 7, 8, right? So adding all those up would give us 8, and 10 stays on the bottom. Okay, so we'll highlight that's our answer. Okay, 3/4. Which expression shows 3/4 as a sum of the unit fractions? So again, boom, we want to narrow in on the denominator. The denominator is a 4. So I automatically see 4s, 4s. Okay. So they're trying to trick me here because they're reversing it. So let's see. Well, let's see. 3 fourths. 1, 2, 3. That equals 3 fourths. 2, 3. That equals 3 fourths. Okay. So what do they mean? Well, now they're talking about unit fractions. They didn't just say which expression shows the sum of the fractions, right? Then maybe they both would be right. But they want the unit fractions here, right? Unit. That's the important word right here, unit. So remember, when we're talking about fourths, 1/4 is the unit fraction, right? So this would be the correct answer. 1/4 plus 1/4 plus 1/4, okay? 2/4 plus 1/4 does equal 3/4, but here they distinctly want the unit fraction, so they want this one, okay? All right, so let's do some clarifying here. When adding fractions, you do not add the denominator. Never, 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 never. You'll never, ever, ever add the denominator, okay? Which can make adding fractions nice and simple. But why? Why don't you add the denominator? So again, let's think candy, okay, or pizza, okay? All right, so let's say you eat 2 pieces, okay? So we have eighths, right? 1, 2, 3, 4, 5, 6, 7, 8. And the unit fraction is 1/8. So let's just say you eat 2/8, you give 1 piece to your younger sibling, and you give 2 pieces to your best friend. Okay, so I have it nice and color-coded for you here. So you have your 2/8, that's you. Then you 1 to your younger sibling, and then you gave 2/8 to your best friend, okay? And if we were to add these up, 2 plus 1 is 3, plus 2 more is 5. So this equals 5/8. Notice we did not add the denominator. The denominator stayed the same. Why? Because the pieces, we didn't get more, right? 8 plus 8 plus 8 would be 24. Do I now have 24 pieces of candy? No, I don't, right? Even if I didn't give some to my best friend, right? Let's say I didn't give that to my best friend and I just had 2 pieces for me and 1 for my sibling, that would be 3, and then 8 plus 8 is 16. Did I get 16 pieces? No, we're talking about from the whole, right? So the 8 is not changing. There's 8 pieces in this pizza, this candy bar, whatever you're visualizing. But we're not getting more of that, especially if we're eating it. It's not multiplying, right? The 8 stays the same, okay? And if I said to you, how much is left? Well, 3/8 is left, right? So that's why we don't add the denominator ever, because our pieces don't get bigger when we start eating them. And we did talk about this. You can decompose a fraction in many different ways. So again, we said that we could do 2/3 plus 1/3, right? That equals 3/3. And 1/3 plus 1/3 plus 1/3 also equals 3/3. But if they're asking you for the unit fraction, that means the one piece out of the total. So know that, we discussed that a little bit earlier. So 1/3, 1/3, 1/3 would be the unit fraction. Okay. All right. And so my little note for you today is to never give up. I want you to remember that Thomas Edison failed more than 1,000 times trying to create the light bulb. And the story is often told as 5,000 or 10,000 times, depending on the version of the story. But when asked about it, Edison allegedly said, I have not failed 1,000 times, because he's learned from his mistakes. If he would have given up, he wouldn't have gotten it. That's a guarantee. If you give up, you're not going to get it. So I promise you, if you keep on going, it's going to start making sense. Start asking yourself questions, trying the things, working it out, drawing it out, taking notes, asking questions. All those things help. So rewatching. You guys watch movies over and over again. Don't be afraid to watch a video again. Pause it, take notes. All right, so it is your turn. So get some paper and decompose these fractions into unit fractions, but you can also try it other ways too, okay? So try these 6 problems, right? The first time you might do them, you might just do the unit fractions. And then the second time, see how many different ways you can create 8 12s, okay? And 4 fifths, 6 tenths, 5 eighths, 4 sixths, and 8 tenths. All right? And you can discuss with your classmates and your partners and see what you all came up with. All right, great job. Until next time, remember, keep studying, keep reading, and always try your best and never give up. Hope to see you soon.